Dear students, welcome to PMDC online lecture room. Today we are going to discuss the topic halogens. This topic is present in chapter number 13, named S block and P block elements of grade 12th chemistry book. This topic is very important from exam point of view. The following two short questions appear in annual BIEC exam 2017 and 2014. Now let's start this topic. This topic includes introduction, characteristics of halogens, uses of halogens, and assignment. We are going to start from introduction. The name halogen comes from the Greek words hales, meaning salt, and gen, meaning to produce. Thus the word halogen means salt producer. They form 7th A group of the periodic table. They include fluorine, chlorine, bromine, iodine, astatine, and tennessine. Tennessine is synthetic element with a symbol Ts and atomic number 117. Look at this slide on which halogen family members are shown. Also, their electronic configuration is shown in the slide. Halogens have 7 electrons in their valence shell. They are highly reactive and thus do not occur in a free state. Fluorine and chlorine are gases, bromine is a liquid, while iodine, astatine, and tennessines are solids. Compounds of halogen are called halides. Look at this slide on which different halides are shown. Halite, which is halide of sodium, fluorite, which is halide of calcium, carnallite, halide of potassium and magnesium, cryolite, halide of sodium and aluminium, silvite, halide of potassium, and silver bromide. Fluorine is pale yellow, chlorine is yellow green, and bromine is red brown. Iodine crystals are shiny purple but easily turn into a dark purple vapors when they are warmed up. Look at this slide on which we can see the pale yellow colored fluorine gas in a tube. In this tube, the green yellow color chlorine gas can be seen. Red brown bromine can be also seen in this tube, and the purple vapors of iodine are shown in this slide. The second part of our today's lecture is characteristics of halogens. The first characteristic is halogens have general electronic configuration Ns2 and P5. They are non-metals and poisonous in nature. The atomic radius increases down the group from fluorine to iodine. Look at this slide on which the atomic radius of halogen is shown. Atomic radius of fluorine is 0.71 angstrom, while of astatine is 1.45 angstrom. It means the atomic radius increases while going from fluorine to astatine due to increase in number of shells. They are the most electronegative element of the periodic table. The electronegativity of halogen decreases from top to bottom. Look at this slide on which the electronegativity of halogen is shown. Fluorine has highest electronegativity 4, while astatine has lowest electronegativity 2.2. The electron affinity decreases down the group except fluorine. For example, the electron affinity of fluorine is minus 3.7 electron volt, of chlorine is minus 4.0 electron volt, of bromine is minus 3.8 electron volt, and of iodine is minus 3.4 electron volt. Look at this slide on which electron affinity of halogen family is shown. The melting point and boiling point of halogen increase down the group due to increase of van der Waals forces. In this slide, the melting point and boiling point of halogen are shown. The red color shows the melting point of halogen and the blue color shows the boiling point. The melting point of fluorine is minus 219.6 degrees centigrade, while the boiling point is minus 188.2 degrees centigrade. But of astatine is 302 degrees centigrade and 337 degrees centigrade. It means from fluorine to astatine, the melting point and boiling point increases due to increase of van der Waals forces. The bond enthalpies decrease down the group except fluorine. This is due to smaller size and high repulsion between nuclei of two fluorine atoms. For example, the bond enthalpies of fluorine is 152 kJ per mole, of chlorine is 242 kJ per mole, of bromine is 193 kJ per mole, and iodine is 151 kJ per mole. Bond enthalpies of halogen can be seen in this slide. Except fluorine, the bond enthalpy decreases from chlorine to iodine due to decrease of attractive forces. The halogen oxidizes metals, non-metals, and many other substances, forming halides. The oxidizing power decreases down the group due to decrease of electrode potential. Fluorine and chlorine are the most powerful oxidizing agents. The third part of our today's lecture is uses of halogens. Halogens are excellent disinfectants. For example, chlorine bleach and iodine tincture. Organobromine compounds are also called organobromides, which are used as a flame retardants. They are also used in lamps and refrigerants. They react with metals to form salts. For example, the chloride ions, usually obtained from table salt, are essential for human life. Fluorine in the form of fluoride is used to provide tooth decay. Statin is used in medicine for the treatment of thyroid cancer. Now dear student, the last part of our today's lecture is assignment. If you have carefully watched and listened our today's lecture, then you can easily solve this given assignment. Thank you very much and take care.